All right. So guys, again, this is going to be about 15, maybe 20 minutes. If you remember from the time that we got together on Tuesday, we talked about the idea that this first unit that we do together is all about teaching you how to work effectively in lab. So guys, today what we're going to do is we're going to honor the fact that in lab, a lot of the time, you are going to be gathering data. And unlike a biology class and more like a physics class, the data that you're going to be collecting in this class many, many times is numerical. And guys, I need to teach you how to deal with and record numerical data. So again, guys, we're talking about probably 15 or 20 minutes here, and then we're all going to get up and collectively we're going to go into lab and we're going to start making some measurements. Now guys, the trick is this. It's not going to be enough to just be able to make these measurements. You're also going to have to be able to deal intelligently with the numbers, and that's actually what you're going to learn to do today. So here's where we're going to start, and this is the stuff you want to get in your notes. So guys, first thing you need to know about the data you're going to collect is actually there's two types of data that you're going to be gathering, and this is information you need to be familiar with. So guys, the first type of data that you're going to be collecting in this class is what is called, and you'll notice on the screen, qualitative data. And guys, just so you know, one of the things you're probably going to take a little bit of time to get used to with me is I don't read my slides. These are supplementary to what we're actually talking about. I wrote them. I'll never be that teacher that just stands here and reads slides to you. So if you're paying attention to me, you also need to pay attention to the board because these are the things that need to be in your notes. But typically, I'm not going to just draw your attention to them. So guys, we're talking about the information that you're going to collect, and you now know there's two types. One of those is what is called qualitative data. But if you're paying attention, you'll notice that the root word for qualitative is quality. And when we say quality, we don't mean good or bad. We mean what are the qualities of the things that you're experiencing. So that makes these things descriptive and derived from observation. And today in lab, you're going to be gathering some qualitative data. What are the qualities of the things that you're interacting with? What do they look like? What do they feel like? How do they behave? So these are descriptions. But then, guys, in addition to that, in addition to qualitative data, there's also what is called quantitative data. And this is the thing that we're going to talk more about today. By the way, guys, if I'm just clicking way too fast, or if you have questions, never hesitate to slow me down or interrupt and ask questions. So I'm guessing you already figured this out. If qualitative data is about qualities, then quantitative data is about quantities, right? So guys, these are measured values. So when we talk about quantitative data, guys, this will always be derived from measuring or counting. This thing weighs 3 kilograms. There are 12 of these in this, whatever that might be, but it's always numerical in nature. But guys, and this is the part that's going to make this a little bit tricky, and this is what we're going to talk about for the next 10 minutes or so, and then we'll turn you loose. Guys, when we talk about numerical data, the thing that you need to get really good at is the thing that's underlined on the screen. You need to figure out how to determine appropriate accuracy. When we make measurements, we want to measure well, but we don't want to measure better than we're allowed to. And so, guys, we talk about this idea of appropriate accuracy. So we're going to dwell on that for a minute. Then I'm going to give you some examples of what that means. And then, guys, again, we're headed next door. So when we talk about appropriate accuracy, there are some rules for this that you need to know. Do you notice I wander around a lot when I teach? Does it make you nervous? I get about 3,000 steps per class. It's kind of an aerobic activity for me. All right, you guys all caught up? Are we doing okay? I'm not trying to hurry, but I do want to give you as much time as I can over in lab. So guys, what is up with this idea of appropriate accuracy? What does it mean that we want to make measurements that are as accurate as they should be? Well, guys, first of all, this is contextual. That this varies depending upon how we make measurements. And that's what we're going to talk about, and then I'm going to show you. So you're going to find in this class that there's actually two ways that we can make measurements. Digitally and then analog. And the rules change depending on how you're doing it. You're going to find the digital ones are the easy ones, and the analog ones are the interesting ones. And you'll have experiences with both when we get next door. So guys, let's talk digital first. This is really simple. When you're using a digital readout, there's no, and I know you don't have context for this, but you will in a minute. Because when you use a digital readout, there's no way for you to round, so you actually need to just write down everything on the display. It's really seriously just monkey see, monkey do, put units on your numbers, you're out the door. So guys, digital measurements don't involve a whole lot of thinking. It's the analog ones that do. So we'll talk about that, then I'll show you. Then we're going to set some ground rules for going into lab. And then we'll get moving. You guys all good? Are you okay? Okay. So guys, let's talk about analog. When we say analog, we mean reading off of a scale. And when I say scale, I don't mean a bathroom scale that tells you your weight. We're talking about reading against a scale. Like, for example, if you measure the length of something with a tape measure, the tape measure is the scale against which you're measuring. So guys, when you're using a scale, this is the most important thing you can write down and remember from the day. When you're using a scale, this is the deal. And guys, I will be gentle with this idea for the first couple weeks, but you're going to find that very, very quickly this is going to become the Achilles heel for some of you because you're not clicking with the idea. So the rule is this: when you use a scale, you estimate one place past the accuracy of the device. And so you're reading that and you're like, what on stinking earth does that mean? Guys, I'll show you in just a second. But I would underline, highlight, put stars, whatever you need to do. Guys, this is a big idea. Don't let it be wasted on you. So guys, that's it. When you're done writing down the word scale, you're done taking notes. Realize you haven't learned anything. You've just been taking notes. So what I'm going to do is actually put these concepts into action and show you what this looks like. But you've got the foundational ideas right now. We're going to flesh this out, and then we're going to get you guys next door. But really, when you're done with this, the only other things you're going to be writing on that notes page are your estimates of a couple measurements that we're going to make together. So you guys all good? You caught up? Okay. So guys, let's talk about digital scales first. This is as easy as it possibly can get. So you walk into lab and you are going to be making some digital measurements. Now guys, here's the deal. In digital measurements, you can't estimate, so you just write stuff down. So you put some objects on a balance, and this might be a little bit hard to read. But guys, you put objects on a balance, you wait for the display to stabilize, and you've got a reading that says 125.30, and then the units off to the side, which are grams. And guys, all you got to do is write it down. But here's an interesting point. Do you write down the zero? And the answer is absolutely. And now you're thinking, why? It doesn't change the value of the number. We'll talk after the weekend. But guys, the bottom line is all you got to do is write down everything that comes up in the display. So say that the next thing that you measure, you grab a thermometer. And the thermometer gives you this reading. And again, guys, you write it all down, including the zeros. And we'll talk about the importance of zeros when we get back from the weekend. You guys get the idea? Pretty straightforward, right? All right, this is where this gets a little bit trickier. Grab your pen or pencil and be ready to write down some answers. So now we're going to talk about analog measurements, measuring against a scale. And guys, remember the rules. You put a star by it. 1 decimal place past the accuracy of the device. So guys, here we go. Here is our scale. Don't write this down. Don't draw it. You're just going to write down the answer. So guys, what are the units for this scale? Tens. Do you get the idea? This scale goes 0 and it goes 10. So the accuracy of this device is tens. So if this thing measures in tens, if this measures in tens, we will then estimate 1 decimal place more accurate. So we will estimate to the ones place. So guys, this is the idea. How long is this yellow stick? Is it 10? Is it 5? No, so you need to estimate how long you think it is, but you're only going to estimate to the ones place because it measures to the tens place. So given your best guess, how long is that stick? Maybe 8, maybe 9. I went with 9. So we'll say that this thing is 9 centimeters long. Now guys, are you sure that it's 9 centimeters long? No, that's an estimated digit, and so you will circle it. In this activity, we are going to circle estimated digits. So now you're going, wait, I'm not quite sure what we're doing yet. So guys, let me give you another example. Here is another scale. Now guys, pause and think. What are the units for this scale? Ones, right? 1, 2, 3, 10, 11. So guys, the units for this scale are ones. So if the unit for this scale are ones, we will estimate 1 decimal place below that. So we will estimate to tenths. So here we go. The unit for the scale are ones. We're going to estimate to tenths. How long is the stick? Is it 8? Is it 9? Which one is it bigger than? 8. So we know it's going to be 8 something. But we're not going to stop there. And this is where we're going to estimate. So if the units for the scale are ones, we know that 8 is right. But now we need to estimate 1 decimal place past. So 8 point what? 5, maybe a little bigger. I went 8.6. But guys, here's the trick. Do we know that the 8 is right? Yeah, but do we know that the 0.6 is right? That's our estimated digit, and you circle it. Starting to get the idea? So let's get a finer scale. So now we've got a scale that goes down to tenths. These are what the tenths look like. So guys, if this scale measures to tenths, what are we then going to estimate to? Hundredths. So guys, here we go. Let me zoom in so you can see it. And actually, I need to go this way so you can see my answers. So we'll do this. Okay, so here we go. So what's our first digit going to be? 7. Do we know Do we know 7 is right? You bet. What about the next digit? Well, we've got 7.5, 7.6. So we know that 0.6 is right. But now we need to estimate. We always go 1 decimal past. So 7.64, I went with 4. But guys, which of those digits do we know are right? The 7 and the 6. What about the 4? So you circle it. Get the idea? Okay. So now guys, let me show you one that might be a little bit trickier. Last one. So what about this scale? What are we back to? 1. So what will we estimate to? Tenths. What do we do with this? It's resting on the 9. So our first digit is obviously going to be a 9. But guys, what do we do from there? 0.0. Does that 0.0 change the value of the number? No, but it does communicate accuracy because it means we estimated out to tenths, we just didn't find any. Now, do we know for sure this is right? We don't. That's our estimated digit, so we'll circle it. But guys, understand zeros in this class communicate information. You get the idea? All right. So gang, you are now ready to go try this on your own. But here's the deal. In order to do this, guys, we're going to go over to lab and we need to establish some fundamentals. I haven't worked with you long, so allow me to just say this and hopefully it's wasted on you. Guys, some of you in your academic careers have got this idea that this is what school looks like, and anything that looks different than this certainly has different expectations. And you walk into lab and you think this isn't school, this is playground. Because you're going to find out quickly that that's not the case. And we'll talk more about this later, but I just need to lay this out for you now. Guys, lab is a wonderful place, but it's also a place that you can get hurt. So we're going to talk more next week, but for right now you need to know, guys, when we get in there, certainly you're going to be in each other's spaces, and that's fine. But guys, we're going to continue to adhere to some of the behavioral standards that make us successful in here. So while we're at this, guys, please only mess around with the things that are laying out for you. You're going to see that there's a lot of other stuff in lab. We're still getting settled from the crazy spring. So just focus on the things that are in front of you. A couple ideas relative to that. One is balances. They're little electronic balances. And you're going to be using them to weigh things. Guys, anytime you weigh something on a balance, make sure the object is not on the balance and hit re-zero. You want to re-zero a balance every time you use it. And then guys, never put water or other liquids on a balance. You see what we've got these little things called weighing boats. They actually look, I don't have one. Oh, darn it. That's all right. They look like this. So guys, when you try to weigh a liquid on a balance, what you're going to do is you're going to put this on the balance first, then hit re-zero. It subtracts out the mass of the weighing boat, and then you can weigh liquids from there. Please don't put liquids on the balance. Then guys, the other thing you need to know how to work well with are pH meters. There are digital pH meters over there. Please guys, when you use them, do not leave them in the solution that you're measuring the pH of. Always return them to the beaker of distilled water. Please don't leave them in the solution that you're measuring. And then guys, finally, you're also going to be working with things called micrometers. When you're working with this micrometer, the first thing you want to do is gently close the jaws and then hit re-zero so that you recalibrate the micrometer every time you go. So other than this, these are just things to keep in mind. So with that said, guys, grab this paper that's in front of you, and we are going to get out of here. So here's what you're going to do. Wait. No. You don't even know what to do yet. So guys, looking at the thing up above, here's the deal. So during this activity, you're going to be making qualitative and quantitative observations in lab. Do you see where we're at? Written this? Yeah, up at the top. So guys, we're going to be making qualitative and quantitative observations. We're not going to be in my lab, however, because my AP kids are in there today. So we're going to go through my lab into Miss Call's lab, and you're going to see 15 stations set up around the outside of the lab. So guys, for these 15 stations, you are only going to do the first 3 columns. The others we're going to do for homework after the weekend, but you're only going to do the first 3 columns. So here's what you're going to do. First thing, the first box, you're going to write down what is the object that you are making a measurement for. Then the second thing that you're going to do is you're going to write down qualitative observations about whatever that object is. You can write down whatever descriptions you want other than color. Because if I allow color, then I just get 15 different colors. So I'm going to ask you to think beyond color. Then guys, after that, you are actually going to record the measurement that's being requested. But guys, just like we did with the activity, the little demonstration, it's going to be the measurement. If it's measured against a scale, then guys, it's going to be with an estimated digit, and you're going to circle the digit that you estimated and then put units on your numbers. So guys, for some of you, you're going to get in there, you're going to try to fly through this, and you're just going to be chicken scratching stuff, and you're totally going to miss out on this. Take your time. Think about what you're doing. You're welcome to work with others if you'd like. And guys, we're going to do these 15 in the next, we've got about half an hour. Now, if you don't get done, this is homework. Going to our website, there are pictures of everything that I'm asking you to measure. We shot pictures of them, so you can finish this from home if you need.